Hello and welcome to Empowered Learning. This will be the first of 3 videos that is about how to find the probability of a data value that's chosen from a particular data set, and what we're given is the population mean and population standard deviation. And I'm going to show you how to do this using your graphing calculator. So the first thing that I want to do before we even get into the whole calculator thing is I want us to intuitively understand what it is that we're doing and why we're doing it. Okay? So this question is asking us to figure out the probability that whenever we choose a data value from a data set is going to be 18 or less. So if we are assuming that the data is normally distributed, what that actually means is that if we're looking at this data and let's say we put it on a normal distribution curve here, then what we're saying is that if our mean is here, and we'll just say that that's 13.45 here, we're saying that within the first standard deviation, about 68% of our data lies there. Within the second standard deviation, we know about 95% of our data is in there. And within 3 standard deviations, we know that about 99.7% of all our data is in there. And so when we say normally distributed, that means we have enough data we have enough data so that if we pull a sample from it, that sample is large enough to be able to say that whatever is happening in the sample, we can say that that same sort of thing is happening in the general population. Okay. And when we're given a population mean and a population standard deviation, that just lets us know the story about how the data is distributed amongst the collection of data that we have. And we look at everything as it's being how far are each data value from the mean data value. Okay. So to put this into perspective, if the mean is 13.45 here, 18 is about there, and what we're trying to do is find the area under the curve of this normal distribution graph from way over to the left to right here at 18. And so you can see that this area covers a vast majority of the area under the curve. So excuse me there. And we know that for this particular type of graph here, we divide this in half. We know that the total probability under the total area under the curve of a probability function is always 1, and half of it is on the left side of the mean, the other half is on the right side of the mean. And all we're trying to do is figure out where this data value lies with respect to that. So that's the first thing that we need to understand. All right, the second thing is, well, how do we actually figure out what this probability is going to be? Well, in your calculator, we're going to use a function called NormalCDF, which is normal cumulative distribution. Okay, and so what the cumulative part as far as that it's adding on area as we move from left to right. And to make my point here, I'm going to show you a z distribution chart just so that you can see how that works. So here for the z distribution chart, everything is written in terms of z-scores. And all that means is that we're trying to look at the data not as what it is in its raw form, but how it looks with respect to the mean. And here you can see that our z-score here starts off at negative 3.4. Of course, it actually goes beyond that, but not much what we have goes beyond negative 3.4 here, because again, this value means that whatever your data value is, it is more than 3 standard deviations below the mean. Okay, and if you're studying in a stats course, you've probably figured out by now that that means that you have some data values that are outliers if it's that far away from the mean. okay? And of course, I'll erase this here, that your mean value would be here, okay? And for this situation, the z-score of 0 corresponds to the data value 13.45. Now, the reason why we call it cumulative is because, remember, we're trying to get to this data value of 18 here. And we haven't found out what the z-score is for that yet, but we're just assuming, hey, this is 18. We're trying to find the area under the curve going from left to right. Okay? And so you can see how we start here, and then on the next page, if it'll go there, you see how these numbers here tend to get positive, and now we've covered more area from left to right. So what it's doing is when we stop here, and let's say the corresponding data value for this is 18, we're trying to figure out what is the cumulative area coming from the left to the right there. And so when we ask the question of, is our data, what's the probability that goes along with a data value that is 18 or less, we're accumulating the area from left to right on this particular normal distribution curve to figure out what the area under the curve is. Okay? So now that we understand what is going on, what we're about to type into the calculator is actually will probably make a little bit more sense. Okay, so I'm going to go ahead and bring in calculator here, and we'll go through the process of showing you how to do this in the calculator. All right, so I'm going to go ahead and bring in a graph and calculator here, and what we want to do, of course, to get to this function NormalCDF that I had written before. I'm going to make this a little larger so that you can see a little better. We're going to press the second button and then the vars button. And above vars is this word DISTR, which means for distribution. And it gives us all the list of the types of distributions that we'll use. For what we want to use here, we are doing NormalCDF. And if you notice here, this lower number is a -1 E99. And what that means is it's the same as -1 times 10 to the 99, which is your calculator's way of saying this is the smallest negative number that I could possibly have. Okay. Now, this particular number here, I'm going to take this away for a second. If we go back to this graph here, this particular number refers to, if we just kept on with this graph here, the smallest negative number that your calculator can come up with is this one. Okay, so we just kept on putting this curve out to where it just can get no more negative than how the calculator can calculate, then that's that value for it. The upper limit that we're going to put in is going to be whatever our data value is. And of course, I'm looking at a Z distribution here, but if we were talking about this just in terms of data values, whatever the data value is for me, and in this case, it's 18. Okay? So when we go back to the calculator, when we do the upper limit is going to be 18 here. Okay? So when we come down, press down, do 18. If you remember, our population mean was 13.45, and our standard deviation was 3.5177. Okay, and I'll take this away again, and we'll go back to the very first page, and we'll see how all this matches up. So here we got population mean, population standard deviation, and then of course the data value we actually talk about here was this 18. So we have all that. Once we do that, we just hit enter twice, and then you'll see that here what it's doing is giving you everything in terms of the way it is actually programmed into the calculator. Now I'll take this away just to make sure that we all understand. So For those of you that have older calculators, this is how you will actually have to type in this data. So here, when you select NormalCDF for that option 2 that you saw earlier, instead of getting that nice little window to where you can just type everything in, you're going to have to type this in like this. And so it starts off with the lower limit, and then the upper limit, and then the population mean, and then the population standard deviation. And so I'll, for those of you that are unfamiliar with how to type this in, like the commas and doing this scientific notation, I'll talk about that once we're done. But once we're at this point here, of course, I just hit enter, and you see that I get this value of 9.0207, blah, 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 okay? And so here, this is what the probability will be, which is roughly about 90.2%. And so what that's saying is that for the population, well, for the data that we're given with that population mean and standard deviation, there's about a 90.2% chance that we'll select the data value from that data set, and it'll be 18 or less. So that's what that actually means. Now, another thing I want to do here is show you how, if we were using everything in terms of z-scores, how we could get this same value here. Okay. So the first thing I want to do before we do that is let's calculate what the actual z-score is. So in general, whenever we talk about calculating a z-score for a given x value, we know that we just do data value minus population mean, all that divided by population standard deviation. So in this case, for the data value 18, we know that our population mean is 13.45 and standard deviation is 3.5177. Okay. And when we calculate that, we'll see that the data value that we get is 1.29345879.4. Okay, so that's the actual data value as far as many decimal places as our calculator can approximate. So now what we're wanting to do is same thing, but now it looks like here in terms of z-score, your mean is going to be a z-score of 0, and your data value of 18 here is now this 1.293 blah, 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 blah number, okay? And again, goal is the same. You want to find the area under the curve from here going all the way back. And again, we'll get the same answer. It's just that what we type into our calculator here is going to be a little different, okay? So let's go back. So if we go back to the second vars and then select option 2, I'm going to go ahead and erase all these values now. Won't let me do it. Okay, so I thought I could go up one, but that's fine. So what we'll do is just type them in. So here for our upper limit, instead of typing in the data value of 18, now we'll type in what the z-score is. And I'll get to it here. It'll be 1.29345879.4. Okay. And then for our population mean, in terms of z-score, this is 0. And for our population standard deviation, remember that in terms of z-score, population standard deviation is just either 1 above, 2 above, 3 above, or 1 below, 2 below, 3 below. So here the population standard deviation is just going to be 1 here, because everything now is referred to in terms of how far the data value is from the mean. Okay, so now we just hit enter, enter one more time, and you see that we end up getting this same data value here. Okay, so the point in me showing you this is that if you have your raw data, you can use your calculator to figure out what the cumulative probability will be if you have that raw data. Okay, if you're given a z-score, or you're asked to calculate a z-score and then figure out this probability of this event happening, you can actually use your z-score to do the same thing. Okay, and so when you first go into this particular function here for the NormalCDF, you see how this is the basic setup. So everything is written, it actually is written in terms of everything being in z-score mode, okay, or as a z-distribution. So your population mean will be 0, your population standard deviation will be 1 here. And if you notice, when we did this the first time, we actually had to change everything. And so we changed it since we had everything in terms of our actual data values. But if you're given everything in terms of z-scores, you can still figure out the probability by just letting your population mean be 0 and standard deviation be 1, and you just find this z-score for the corresponding data value that you're referring to. Okay, so I hope this video helps to shed some light on how we use our calculator to be able to figure out the probability of a particular data value happening. Of course, if it's specifically in the case of what's the probability that we're going to choose a data value and it's going to be this data value or less. Okay. Now, part 2 of this video series is going to go over how do we do the same thing that we've done here, but we do it by hand by using a z-distribution chart. And so some of you may be wondering, well, yeah, how do we do that? So I recorded a separate video for that so that you can check that out. The third video that I will do will refer to just another type problem, to where we're trying to find what is going to be the probability that the data values that we choose is going to be in between two numbers. And so we can see how we use that. And what I'll do for that one, I won't go through the whole linear interpolation thing, but as I'm going to go through in part 2 video, but in part 3, I'm going to use the graphing calculator to help us get those values. Okay. All right. So again, I hope this video helped. Let me know if you need to see anything else. Take care.